Good morning, everyone. Welcome back. Thank you for joining us. I'm Steve,
And I'm Scott.
and together we're Backyard Musings, broadcasting live from the moon.
And and today we're talking about some interesting information about the moon and the Apollo 17 mission.
Yeah, what you're seeing
Go.
right now is a photo from the excuse me, a photo from the moon that was taken by the astronaut on the moon. This wasn't on a soundstage. It's not a conspiracy. This is a real deal, right?
This is way before AI.
Way before. This isn't Photoshop. And the dude's collecting samples here. So let's get on with the story here. There we go. Scientists have found that a sample of the moon brought to Earth in 1972 by Apollo 17 astronauts contains a ratio of sulfur isotopes very different to what we see on Earth. Well, it's the moon, I guess, but there's a lot of theories out there that the moon came from the Earth, like an explosion and the accretion disk formed into a moon. Anyways, we've talked about that before in different segments before. It's a discovery that could either tell us about the giant impact that formed the moon or about the moon's earliest history. When the 6 Apollo missions that landed on the moon, there's Apollo 17, but there's 6 Apollo missions that landed, right? So some went
Starting with
in
11.
orbit. Some went in.
11 was the first. Yeah.
Yeah. When the 6 Apollo missions that landed on the moon returned home, some samples of lunar rocks and regolith they brought with them were stored, pristine and unopened. This is because scientists wanted to preserve them for a later date when more advanced instruments could be used for their analysis, kind of like DNA sampling kits from like a murder or something like that 30 years ago. They hold on to the evidence.
Right.
The findings were published on September 10th, 2025 in the Journal of Geophysical Research, Planets. Would you like to know more?
Yeah. So 11 was the first one. And if you all remember from the famous movie with Tom Hanks, Apollo 13, they didn't make it. They had to abort and come back. So in recent years, NASA has been gradually releasing these stored samples from the Apollo Next Generation Sample Analysis Program to researchers armed with instruments that hadn't even been invented in 1972. Among those instruments is a secondary ion mass spectrometer employed by a team of researchers led by James Doughton, an assistant professor of Earth, Environmental, and Planetary Sciences from Brown University.
Doughton's team requested one of the double drive tubes, which Apollo 17 astronauts Gene Cernan and Harrison Schmitt pushed 23.6 inches into the lunar regolith, sampling material from just beneath the surface and storing it in a metal cylinder. This sample has been left untouched since it arrived on Earth. I think that's the picture that you're seeing.
Yeah, he's holding it there. It looks like he's holding a rod or something like that. Yeah, that's the drive tube. So,
yeah.
Okay. In particular,
I'd like to know: is that buggy still on the moon? I don't think they took it back with them.
No, they did not. Yeah, all the rovers or whatever they used, they left all that stuff there. Now, I don't know whether it's still there or not. I have no idea, but I would imagine it would be. So. Okay. In particular, Doughton's team wanted a sample of volcanic rock that was originally part of the moon's mantle. Scientists think that the moon formed on a Mars-sized protoplanet called, is that Theia?
Yeah. We've talked about that before, yeah.
Yep. Slammed into Earth, forming debris that coalesced into the moon. Therefore, the chemistry of the lunar mantle can teach us about this giant impact and the material that was remade into the moon. I think it's green cheese.
But, green cheese.
Yeah.
Man in the moon. Previous studies of lunar samples have found the ratio of different isotopes of oxygen in the moon's mantle broadly match that on Earth, suggesting the moon is formed mostly of debris from Earth. Returning to the team's analysis, an isotope is an atom of a specific element that has the same number of protons but a different number of neutrons. And Doughton wanted to check the isotopic ratios of sulfur, which a secondary ion mass spectrometer can measure precisely.
Quote, I was targeting sulfur that had a texture that would suggest it was erupted with a rock and not added through a different process, Doughton said in a statement. However, the analysis showed that compared to the ratios of different isotopes of sulfur on Earth, the moon seems to be depleted in sulfur 33, meaning sulfur with 33 neutrons, which is one of the 4 stable sulfur isotopes. Sulfur 32, sulfur 34, sulfur 36 being the others.
Oh, that's fascinating. What happened to sulfur 35?
Yeah, I don't know.
Huh. Quote, before this, it was thought that the lunar mantle had the same sulfur isotope composition as Earth, said Doughton. That's what I expected to see when analyzing these samples, but instead, we saw values that are very different from anything we find on Earth. My first thought was, holy schmolies, that can't be right. Holy schmolies, Batman. So we went back to make sure we had done everything properly, and we had. These are just very surprising results.
Doughton's team have come up with 2 possible explanations. One is that the isotopic ratios of sulfur are a legacy not of Earth, but of the chemical composition of Theia, and that more of the moon is made from debris originating from ancient protoplanet that had been thought.
The other possibility is that sulfur 33 became depleted after the moon formed. It is suspected that the very young moon was wrapped in a thin atmosphere, and if sulfur was present in this atmosphere, it could have interacted with ultraviolet light from the sun. The chemical reactions resulting from this interaction could have led to a depleted amount of sulfur 33. If this is the case, it means the altered sulfur in the moon's early and brief atmosphere must have somehow been transported from the lunar surface down to the mantle. Then it would have erupted back to the surface at a later date.
Quote, that would be evidence of an ancient exchange of materials from the lunar surface to the mantle, says Doughton. Going on with the quote, on Earth, we have plate tectonics that does that, but the moon doesn't have plate tectonics. So this idea of some kind of exchange mechanism on the early moon is exciting.
For now, there's no way to know which explanation is the correct one. However, if future missions can measure the isotopic ratios of sulfur on other bodies in the solar system, such as Mars and asteroids, it could provide clues as to whether the sulfur 33 depletion on the moon is a legacy of its other parent Theia, which could have been made of the same material as Mars and asteroids, or whether it is a consequence of chemical reactions that took place after the moon had formed. Basically, they don't know. So there you
Yeah,
have it.
they don't. And it's interesting because this planet is just dirt and rock, basically, right?
Yeah.
There's no vegetation on it. There's no
I don't
water.
think there's magma underneath either. Yeah.
Yeah.
Well,
So,
there's ice. Could be ice.
yeah,
With,
we've talked about that, right? We talked about
yeah.
the possibility of ice below the surface. But right now, when we see it or when they walk on it, it's just basically dirt and rock.
Mhm.
And so it's just weird how, I mean, was that a planet that was formed by Heavenly Father, creating other worlds, right? And it just didn't work out, or it wasn't going to happen, or whatever. I mean, I don't know. It's kind of weird. So,
Well, the
anyway.
theory about Theia slamming in and then the accretion disk that forms around the Earth, and then over billions of years, it coalesces into a moon. That's probable. You know,
You buy that.
I'd buy that. Yeah. Yeah.
Okay. Well, I need a little bit more. I need a little bit more evidence on that one because it just,
Yeah.
I don't know. It's just too weird, and it's not that far away from us. That's the other thing. It's just
Right. Yeah.
so weird. Why wouldn't it be similar to our planet? And maybe it was at one time.
Mars has a planet, has a moon also. Mars has a moon.
Right.
Yeah.
Yeah. So, and other planets too. So.
Yep. Thanks for joining us. Catch you in the afternoon.
We'll see you later this afternoon. Thanks.